Hello, in this video I will introduce implicit differentiation twice, and the steps are finding second implicit differentiation. So let's talk about the steps of finding second implicit differentiation twice. So when you see this d square y over dx squared, that just simply means you're taking the derivative implicitly twice. So the first step is find dy dx and box the answer. The reason why why you should box the answer is because you're going to substitute because you're going to substitute dy dx because when you actually solve for it, when you go to step 5, you're going to have a dy dx, and then you're going to substitute dy dx, whatever that answer is. And then step 2 says continue deriving implicitly twice. So do all the steps, just take implicit differentiation twice. Step 3, get anything with a d square dy dx square on one side, and anything without a d square dy dx square on the other side of the equation. So it's just like when you find dy dx, you had to get anything with the dy dx on one side, anything without it on the other side. It's the same concept. Step 4, factor out d squared dy over d squared dx. And then substitute dy dx with the answers you bought in step 1. Step 5, simplify and solve for d squared y over d squared x. For example, steps 1 through 3, find d squared y over dx squared in terms of x and y. Okay, so let's start with example 1. So what's the derivative of x squared implicitly? It would be 2x, and then you do have the option putting dx over dx. But you do realize that this becomes 1, so you don't really have to. The derivative of y squared in respect to x is 2y dy dx. And then on the right side, the derivative of 36 or a constant is 0. So we have 2x, because this cancels, plus 2y dy dx equals to 0. And then let's get remember step 1 says we have to get dy dx by itself, so let's do that first. Let's solve for dy dx. So I'm going to subtract 2x, so you get 2y, and then solve for dy dx by dividing both sides by 2y. So you get dy dx. Let's see, the 2's cancel, so you're left with negative x over y. Okay, now what we're going to do is it says we should box it because we're going to substitute that back in. So now we got to take the derivative of negative x over y one more time, right? So you could say that d squared okay, so let's take the derivative of negative xy. Okay, so how do we take the derivative of this? We're going to apply quotient rule, right? So if f is negative x, f prime would be negative 1, g is y, g prime is 1 dy dx. So if you apply the quotient rule, quotient rule is f prime of g minus g prime of f all over g squared. Okay. So you can say d square y over dx squared is f prime, which is -1, times it by regular g, which is y, minus bracket g prime, which is 1 dy dx, and then f is -x, bracket, all over g squared. So that is y squared. So this is going to be -y. 2 minus this becomes a positive. So wait, what is 1 times dy dx times -x? It's -x dy dx, and then you have an extra minus, so that's positive. All over y squared. So I'm glad that we boxed dy dx because now we're going to substitute dy dx with that. Okay, so that it's going to be -y plus x, and then dy dx is -x over y all over y squared. Okay. So your final answer is going to be that you can finally say that d squared y is going to be -y plus, or actually not plus anymore, -y, and then negative positive x times -x is -x squared over y all over y squared. Now we have what's called a complex fraction, so we got to simplify. So this is your numerator, and this is your denominator, correct? So let's fix that up. So let's simplify the numerator. Our GCF is, so this has a denominator 1, this has a y, so my GCF is actually y. So you're going to multiply top and bottom by y. So you get -y squared minus x squared all over y, and then it's divide all over y squared, so it's complex. If you simplify this, this is going to be -y squared cross multiply. So your final answer is going to be here. Let me write it here. When you cross multiply, the numerator will be -y squared minus x squared all over, and then y times y squared is y cubed. So yeah, that's example 1. Go ahead and pause, press pause to copy the work. Okay, let's move on to example 2. We have x squared y squared minus 2x equals to 3. So how do we take, we're going to first find dy dx. So my f, so how do you take the derivative of this term? So we have we have like 3 terms, right? So f is x squared, x squared, and then f prime is 2x, and then g is, so I'm taking the derivative of this by using product rule, right? And then g is y squared, g prime is 2y, and then because we have to take it implicitly, you have to add that dy dx. On here, the x squared, you could have added the dx over dx because we're taking it in respect to x, but what happens to dx over dx? It becomes 1. Okay, so let's apply the product rule. So it's f prime of g plus g prime of f. So f prime is 2x times g, which is y squared, plus g prime, which is 2y dy dx, times it by f, which is x squared. And then if you FOIL this out, this is 2x y squared. This is going to be plus 2x squared y dy dx equals to 0. And then just, so step 1 says we do kind of solve for dy dx. So I'm going to subtract 2x y squared. And then you have 2x squared solve for dy dx. So you have dy dx equals to, if we simplify this, the 2's cancels, this x cancels, this becomes a 1, y squared over y, this y cancels, this becomes a 1. So you're left with negative 2y, right? This x cancels. And then this becomes an x, and then this, the y's cancel. So y squared, yeah. So you have negative 2y over x. Let me double check my work. Yes, that's correct. Okay, so this is what dy dx is. It's not our answer. We should box it because we're going to substitute it. So now we got to take the derivative of this again, right? So you could say that so what's my f and my g? So my f is, we're going to take the derivative of negative 2y over x in respect to x again. So we have to apply what's called the quotient rule again. So my f is negative 2y. F prime in respect to x is negative 2. And then you do have to add that dy dx. And then g is x. G prime is 1. And then respect to x, it's dx over dx, which really becomes 1. So we're going to apply the quotient rule, and the quotient rule, if you forget, it's f prime of g minus g prime of f all over g squared. So f prime is negative 2 dy dx. And then g is x minus bracket g prime, which is 1, and then f is negative 2y all over g squared, so that's x squared. So what I'm going to do is simplify, and I'm going to substitute dy dx with negative 2y over x. So let me do that. Dy dx is negative 2y over x times it by x minus, what's 1 times negative 2y is negative 2y, and then there's also a minus. So that's negative. So 2 minuses becomes a positive all over x squared. So this would be negative 2 times negative 2y times, okay, this x cancels. So you're left really just left with negative 2 times negative 2y, which is positive 4y. 2y over x squared. And then we simplify the top. Yes, we can. Wait, let me see if I made a mistake. So dy is negative 2y over x. Just double checking work. So we get negative 2y, so f is negative. dxg is x. Okay. And I guess that's our final answer. So our final answer on the top is going to be 4y plus 2y is 6y over x squared. So this is right here. This is your final answer, which is d squared y over dx squared. So it's this one right here. Okay. I'm going to end that, even though there's another example, I have to end it because I have to, I don't want to make the videos too long. Yeah. So the next video will be example 3 and then the quiz. Thank you. Bye-bye.